Hello class, our learning intention today is I can multiply or divide rational expressions and write excluded values from the domain. We are going to do a few examples together from your guided notes, so please take out your guided notes that accompany this video. Before we begin multiplying rational expressions, we are going to write down some steps to help us when multiplying these rational expressions. So our first step is that we want to factor the numerator and denominator. And I'm going to say completely to make sure it's fully factored. And then you do also want to write restrictions on the domain, as we have discussed the restrictions that your denominator cannot equal 0. After you factor your numerator and denominator, then step 2 is divide out common factors. I sometimes refer to step 2 as simplifying or canceling. And then step 3 is multiply straight across for final answer. And your answer should be multiplied and fully simplified. So let's take a look at our problem that we are going to begin with. Notice that when you're multiplying rational expressions, it's exactly the same as you multiply fractions. So you're going to find that we're doing the same thing, we're just using algebra. So for problem 2, what is the product of x squared plus x minus 6 over x minus 5 times x squared minus 25 over x squared plus 4x plus 3 in the simplest form? And we must state restrictions. So step 1 is factor x squared plus x minus 6 is a general trinomial where a equals 1. So it factors to x plus 3 times x minus 2. Your denominator cannot factor any further than x minus 5. Now also factor your second fraction. X squared minus 25 is a difference of two squares, which factors to x plus 5 times x minus 5. X squared plus 4x plus 3 is a general trinomial whose a value is equal to 1. So it factors to x plus 3 times x plus 1. Now step 2 is what I'm going to call cancel your common factors. So look between the numerator and denominator. If you can divide out common factors, they will divide away because they equal 1. So x plus 3 over x plus 3 divides, and x minus 5 over x minus 5 divides. Your last step is multiply across. So when you multiply across, we are left with x minus 2 times x plus 5 all over x plus 1. And now let's make sure we state those restrictions on the variable. So go back and look when you factored what was your denominator. And if we cancel an x minus 5, then that means our x cannot equal 5. If we cancel the x plus 3, that means our x cannot equal negative 3. And if you would like to include that x cannot equal negative 1, that number is also excluded from your domain, because all of these numbers would result in the denominator equal to 0. Flip to the second page in your notes packet, and you will have another example of multiplying rational expressions. So you're going to want to follow your steps to factor, then divide away common factors, and then multiply across. So I'm going to have you try this one on your own. Don't forget your restrictions on your domain at the end. Now that you have finished your multiplying example, let's look at our next problem, which is dividing rational expressions. If you remember how to divide fractions, you divide them by multiplying by the reciprocal. So we need to do this one step. Sometimes we call it keep, change, flip. And then we will change our problem to multiplication and do it exactly how we did the previous examples. So if we're going to multiply by the reciprocal, keep your first fraction the same of 2 minus x over x squared plus 2x plus 1, but multiply by the reciprocal, meaning flip your second fraction to x squared minus 1 over x squared plus 3x minus 10. This is how we divide rational expressions. Now you are going to follow your steps for multiplication. So our first step is to factor the numerator and denominator. So notice that 2 minus x is in the wrong order. So we want to switch 2 minus x to be negative x plus 2 because we want our x to be first. And then we can factor negative x plus 2 by pulling out a negative 1, which leaves us with x minus 2 inside. So 2 minus x is the same as negative 1 times x minus 2. Now let's factor the denominator. X squared plus 2x plus 1 factors to x plus 1 times x plus 1. X squared minus 1 factors to x plus 1 times x minus 1 because they are conjugates. And x squared plus 3x minus 10. Think, what multiplies to negative 10 but adds to positive 3? Hopefully you've picked x plus 5 times x minus 2. Now you are ready to start step 2, which is to cancel common factors. So I see x minus 2's can cancel, and an x plus 1 can cancel. Step 3 is going to be to multiply across. So when you multiply across, we get negative 1 times x minus 1 in the numerator, and x plus 1 times x plus 5 in the denominator. And now we need our restrictions on our domain. So notice that our original denominator was x squared plus 2x plus 1 and x squared minus 1. You want to look at their factored forms to tell what your restrictions would be. So those factored forms, we have x plus 1 times x plus 1, and also your x plus 1 times x minus 1 got flipped on top. So those used to be denominators, so you do need to include those in your restrictions. And then you also have your denominator that was created when you flipped your fraction of x plus 5 times x minus 2. All of these factors create restrictions on your domain. So for this denominator, x cannot equal negative 1. For this, which used to be a denominator, x cannot equal positive 1. And then for this denominator, x cannot equal negative 5 or positive 2. Now that you have multiplied across and written your restrictions, you have finished the division of this problem. Go ahead and flip to the last example. The last example is a division problem that I would like you to try on your own. So follow your steps to multiply by the reciprocal, and then follow all your steps to multiplication.